Hello, here's Jeffrey Fox again. Um, we're going through these different access patterns. In the last lesson, we did science case. In this lesson, we'll do the last five of the general access patterns, which are actually also relevant to some science. But we will not go through one of the key features of the science, which is the difference with the way the data is gathered and batched and locally processed. So that's what he says here. It's the remaining five general access patterns described with a more enterprise point of view, because Bob Marcus invented these, and that's his great expertise. All right, we have our beautiful users here, such as ClipArt and Microsoft PowerPoint. And what are they doing? They're trying to interact with the big data software stack, and it has here 4 layers, which we can discuss. Actually, first, so we can actually say what we're doing here. These users are telling a system what to do with the data. They're specifying the analytics, running a clustering, running a blast job, trying to do a histogram to find the Higgs boson. And then that actually prepares an interactive visualization, because the eye is so much better than um, when it looks at pictures than when it looks at numbers. And so that visualization is then interactive with back and forth, rotating it, changing parameters, and so on. And here we have this orchestration layer, which is almost inevitable, because when we're doing all of this, we're going to be doing different things. We're going to be running our favorite Mahout clustering algorithm, and then followed by our favorite visualization preparation algorithm. So this means we'll have multiple jobs, and that's precisely what orchestration does. It makes those jobs talk to each other properly. This then sits on the standard horizontally scalable layer, Hadoop, Spark, Giraffe, Pig, Twister, Harp, etc. And that sits on top of the data storage, which here we've just left at the standard big data thing, HDFS, HBase, MongoDB, etc. So this is a really sort of simple case. It summarizes a large number of problems, and it's actually true both for the enterprise doing data analysis and for science. Science would just differ by what happens here, how the data arrives in this storage. All right, here we have something which actually, I guess, variant of this is some relevant to science. Here we have our data of various sorts, filing cabinets, streaming data produced by a machine, or even coming out of a database. That's probably the most common in the enterprise. That gets loaded into the data storage. Of course, we're doing this loading so we can use the very efficient, highly scalable, parallel big data processing here. This is the Hadoop Spark Giraffe layer, because that's more efficient than traditional databases for very large processing. And they're going to transform the data in some fashion, which is actually going to be specified by this charming user here. And then they're going to actually end up by putting it into a data warehouse, which is almost by definition the place that our user uses to query the data interactively to find out about the future of the world, or the future of the company, or what's happening in science today. So this is, again, a simple variant of what happened before. We have the same two typical horizontally scalable programming, data storage, and we have somewhat different beginning and ending from before. Here is an example from Teradata, which is a major database company. It was actually one of the very first to do parallel computing. I remember how that started many, many years ago in the early 80s. And here we have all our people, engineers, data scientists, quants doing the fiscal analysis for Wall Street, business analysis, deciding how to market things. Here we have all the things we bring to bear, Python, R, we've seen all that. SQL MapReduce, that will be their version of Hive, and so on. And they have their traditional all these big vendors have the traditional approach over here, which they also supplement by the big data stack approach, and they try to bring them together. We sort of saw that by using this MapReduce portfolio to move it to the warehouse, which is shown here. So this is just Teradata's variant of that previous graph. Here we have a slight variant of it, where instead of going to a data warehouse, we may put it in an archive. These are the query engines. Hive is SQL on Hadoop. Drill is a variant of that. And of course, we have Hadoop as Spark, Giraffe as well. Here are all our transformation tools. Typically, we might actually put Hive and Drill above Hadoop and Spark, etc. And here we have our storage, and we have exactly the same sources of data. And then instead of sending it to a warehouse, we put it into our archive for looking at later if we really need to. So that's a variant of the warehouse problem. Here we have a somewhat different problem, which is actually similar to what you see in science a lot. You need to combine data from lots of different sources. Here we have lots of clouds. I showed you a few clouds here. In some graph, actually earlier we compared Google Drive, iCloud, Box, Dropbox, OneDrive, and so on. Here we have our streaming data going directly. These are coming from the outside of our organization, and then we might have our own data. Here we are. We're a giant consumer company with our own data, or we're a giant search company, and we want to, of course, combine them so we can compare what people we deal with do, which is this data, with what the rest of the world does, which is this data. And then we have actually the identical stack here from before. Same old storage, same old big data storage, same old horizontal scalable big data software, and the same old analytics. And then we have our charming decision maker looking at all of this and making the decision which will make another $1 billion for our company. Here's an example of this, which comes from, which was chosen by Bob Marcus, comes from a particular source. Here we have the enterprise warehouse and a particular commercial application, and we have these different sources. Obviously the weather is correlated with how people feel and whether they want, what type of clothes they want. Here we have commodities coming in, the price of nature of commodities, and here we have data from industry. All of this is joined together with our own local data, and this produces the decisions that tell us what to do. So this is just one example of this idea of that, and the critical thing to do, we have to integrate data. Now that's because, remember, we need to bring the computing to the data. That's tricky. While your data comes from different sources. So what you see here is a sort of trivial strategy. We first bring all the data to the same place, then we bring the computing to that place. Whether that really works and what the cost of that compared to other methods like doing a distributed algorithm remains to be seen. I don't think that answer is very well understood. Here we have the final example, scenario, example 10. Which is actually similar to what we had before, except it has this crucial orchestration layer spelled out a bit more, which is the workflow showing different analytics, a clustering followed by a multidimensional scaling, followed by a visualization package. We have the same bottom two layers as before, and we have our favorite analyst both specifying what to do and looking at the final answer. And if we added again data staging at the bottom here, we would get a very, very important and common scientific case. And we have an example of that given in the next slide, which comes from Hortonworks. Hortonworks are a major sort of, this is a very important industry. It comes from people who either They package the Apache Big Data Stack in various ways, and they ingeniously donate to Apache some of their own software, which locks people on into their own software. Hortonworks is like that. Cloudera is like that. And here is this is about Yarn, which was, I gather, I think an invention originally of Hortonworks, but now it's part of Hadoop and in open source. And it shows how you can actually integrate all these different components in this single Yarn scheduling system. So that's a typical example of how we orchestrate a lot of different approaches to the problem. So that's the end of our discussion of data access. When you do your problems, your data will have to be accessed. So you might come back to these patterns to see which of these patterns fits the way your data gets produced, the data gets processed, and the data gets analyzed and looked at by your company analysts. Thank you very much. The next part D of this unit, we'll discuss how the Apache Big Data Stack fits into this in a little more detail.